Hello guys. Before we begin our topics, I would like to introduce you guys with our team members. First, we have Danish Hakim bin Muhammad Shukri, and then we have Ahmad Lufi Hadi bin Amir, Khairul Iman, Muhammad Wafiq bin Abdul Malik, and myself is Muhammad Adam Atullah bin Muhammad Kamal. So, our group chose chromatography as a topic. What is chromatography? Chromatography is a process for separating components of mixture. To get the process started, the mixture is dissolved in a substance called the mobile phase, which carry it through a second substance called the stationary phase. The different components of the mixture travel through the stationary phase at different speeds, causing them to separate with one another. The nature of the specific mobile and stationary phases determines which substance travel more quickly or slowly, and this is how they are separated. These different travel times are termed rotation time. Chromatography in toxicology. Chromatography is a vital analytical technique used extensively in toxicology for the separation, identification, and quantification of complex mixtures of chemical substances. Here's an overview of its application in toxicology. First, we have gas chromatography, we have liquid chromatography, and then we have TLC, which is thin layer chromatography.
Okay, so hi, my name is Danish Hakim. I would like to explain to you guys about the theory of chromatography in toxicology (TLC). Thin-layer chromatography (TLC) is a popular method in toxicological investigation because of its ease of use, quickness, and capacity to separate a variety of substances. The following fundamental ideas are included in the toxicological theory of TLC. The first one is separation mechanism. TLC separates compounds based on their differential partitioning between the stationary phase absorbent coated on a plate and the mobile phase solvent. Compounds with higher affinity for the mobile phase travel faster, while those with higher affinity for the stationary phase move slower, resulting in separation. The second one is retention factor (RF). The ratio of the compound's travel distance to the solvent Franz travel distance is known as the retention factor (RF). This typical value for particular drug under particular TLC circumstance, temperature, absorbent, mobile phase, and etc. If values are compared to reference standards in order to identify compounds. The third one is selectivity, comparing the RF values obtained from the use up to 8 different solvent systems helps improve the selectivity of TLC. By increasing the number of associated RF values, this method, also referred to as the mean least length method, improves the reliability of compound identification. The last one is standardization. Toxicological analysis requires TLC system standardization for consistent and repeatable results. This entails applying development conditions, mobile phases, and adsorbents that are standardized. It is necessary to take into account how different absorbents types, layer thickness, and sample loads affect the RF values.
I'm going to explain about methodology. The best chromatography technique in terms of simple, cost-effective, and fast is thin layer chromatography. It is used also widespread, being able to detect drug use in the body and various other use. To prepare the sample for thin layer chromatography, we need to extract the analyte from the biological sample using a suitable solvent such as methanol or ethanol. Then filter and concentrate the extract if needed. For preparing the TLC plate, we need to mark a baseline with a pencil about 1 to 2 cm from the bottom and make like pencil marks to indicate the spot where the sample will be applied. Next, we use a capillary tube or micropipette to apply small concentrated spots of the sample extract onto the marked baseline and let them dry completely. Pour the mobile phase solvent into the developing chamber to a depth of about 0.5 cm. Close the chamber and let it equilibrate with the solvent vapor for a few minutes. Place the spot TLC plate in the developing chamber with a baseline above the solvent level and then close the chamber and let the solvent ascend by capillary action. Remove the plate when the solvent front is 1 to 2 cm from the top and mark the solvent front with a pencil. Measure the distance traveled by each spot from the baseline RF value and compare these values with unknown standards to identify the substance present. If you all can see the picture in these slides, we can see how to make the correct thin layer chromatography. A TLC plate is a stationary phase placed in a TLC chamber where there is a mobile phase. What is mobile phase and stationary phase? The mobile phase is the solvent or solvent mixture that moves through the stationary phase, carrying the analytes with it. It is responsible for the separation of the components in the sample. And the stationary phase is the solid phase coated on a glass, plastic, or aluminium plate. It remains fixed and interacts with the analytes as the mobile phase passes through it, aiding in their separation.
So next, from my part, I'm going to talk about example of results, application TLC in toxicology. For the method part, sample preparation, urine samples collected for toxicological screening, and then samples were stored on a TLC plate which was then developed in a suitable solvent system. For the visualization on the TLC plate, the developed plate was examined under the UV light to identify the presence of toxic compound. This is the part of the results where TLC identified multiple toxic substances including amphetamine and opioid. For the visualization, the distinct spots on the TLC plate correspond to the different toxic substances, matching them with reference standards. So this example highlights the use of thin layer chromatography (TLC) in toxicology, demonstrating its ability to quickly and effectively identify toxic substances in biological samples. TLC remains a critical tool for preliminary toxicological screening, offering rapid and reliable results.
Hi, I'm going to give you an application of TLC in human life. The first one is pharmaceuticals, identification of active ingredients. In the pharmaceutical industry, TLC is a valuable method for identifying active ingredients in a tablet. To identify active ingredients in a tablet using TLC, crush a small portion of the tablet and dissolve it in methanol or ethanol. Apply a drop of this solution to a TLC plate. Place the plate in the chamber with the solvent and let the solvent rise. Once near the top, remove and dry the plate. Use UV light or a reagent to see the spots. Measure the spot distances, calculate RF values, and compare them with known standards to identify the ingredients. The second application is food industry, detection of food additives or contaminants. In the food industry, TLC detects additives or contaminants by extracting them food with a solvent. Apply a drop of the extract to a TLC plate and place it in a solvent-filled chamber. Let the solvent rise, then remove and dry the plate. Visualize the spots with the UV lights or staining, measure spot distances, calculate RF values, and compare with standards to identify the additives or contaminants. The third application is environmental analysis, detection of pesticides. In environmental analysis, TLC is used to detect pesticides in soil or water. Extract the pesticides using an organic solvent. Apply a drop of the extract to a TLC plate and place it in a chamber with the solvent. Allow the solvent to rise up the plate, then remove and dry the plate. Visualize the spots using UV light or chemical reagents. Measure the distances the spots travel and calculate their RF values. Compare these values with known standards to identify the pesticides present in the sample.
So in conclusion, TLC's role in toxicology underscores the importance of a sensible and efficient analytical method, ensuring safety health in various fields from medical diagnostic to environmental monitoring. As technology advances, TLC continues to evolve, maintaining its relevance and utility in modern toxicological practices.